Assalamualaikum warahmatullahi wabarakatuh.
Good morning, ladies and gentlemen. Welcome to the 7th International Conference on Sustainable Agriculture and Environment. For the first, let us introduce ourselves.
My name is Selvira Rizky, and here I am with my partner.
Okay, Viro, and I am Graciela Amaris. Today we will be your master of ceremony for the event.
Of course, and it is such an honor for us to welcome you guys here as participants.
Okay, for the first, dear Rector of Universitas 11 Maret, what we respect, Head of Institute of Research and Community Service, Universitas 11 Maret, and Dean of the Faculty of Agriculture, Universitas 11 Maret.
Dear speakers, Professor Dr. Heri Utomo from Louisiana State University, United States of America, Professor Dr. Ahmad Yunus from Universitas 11 Maret, Indonesia.
Dear Professor Taifo Mahmud from Oregon State University, United States of America, and also dear Dr. Betty Suryawati, PhD, from Universitas 11 Maret, Indonesia.
Dear Dr. Mithat Direk from Selçuk University, Turkey, Professor Dr. Muhammad Sarjan from Mataram University, Indonesia, as well as our beloved participants here.
Yes, it is our pleasure to welcome you to the 7th International Conference on Sustainable Agriculture and Environment. This conference is organized by the Faculty of Agriculture and Center for Biotechnology and Biodiversity Research and Development, Universitas 11 Maret, in collaboration with Selçuk University, Turkey, and Mataram University, Indonesia. This conference is also supported by Indonesia Diaspora Network United.
Okay, this event is intended for stakeholders in agriculture-related sectors such as researchers, scholars, engineers, resources managers, students, policymakers, and all those interested in agricultural and environmental sciences. This conference provides a great opportunity to build worldwide networks as well as to share knowledge and experiences on the current advances in sustainable agricultural and environmental topics.
Wow, very interesting. As informed, this conference will be held online due to current COVID-19 pandemic. Okay, so before we begin the conference, we would like to inform you that there will be 3 sessions with 2 special invited speakers and a moderator in every session. To officially open the conference, we would like to begin with an opening speech from presentation of the Rector of Universitas 11 Maret, Professor Ahmad Yunus. Would you please welcome Professor Ahmad Yunus?
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. The first, the Dear of Excellency, Professor Taiful Mahmud from Oregon State University, and also distinguished Professor Heri Utomo from Louisiana State University, distinguished Dr. Mithat Direk from Selçuk University, Turkey. This is our close relation with UNS, distinguished Professor Sarjan from Universitas Mataram, and also the Honorable Dr. Betty Suryawati from Universitas Plus Maret. It gives me great pleasure to extend you all our high appreciation to participation and joining the 7th International Conference on Sustainable Agriculture and Environment on August 27, 2020. This conference is held by online due to the current COVID pandemic circumstance and proudly organized by the Faculty of Agriculture and Center for Biotechnology and Biodiversity Research and Development, UNS. Moreover, the conference is also supported by the Indonesian Diaspora Network United, IDNU, especially for the diaspora in US. The 7 ICSAE conference belong to ICSAE conference series. The previous conference was held in Solo on 2013. This is the first time, and the second is in Konya, Turkey, held by the Selçuk University, and the third is in Warsaw, Polandia, and the fourth is come back again in Solo in 2017, and in 2019 we held this conference in Hammamet, Tunisia, North Africa. 7 ICSAE will be the flagship conference for researchers, students, and professionals in the area related to agriculture and environment. Sustainable is the key word in agriculture and environment management to assure global food security and maintain high quality of human life. The sustainability concept of the environment management in global scope is involving management of the ocean, freshwater system, land and atmosphere, and also energy. According to that, this conference is held to identify ideas, practice, and policies that constitute our concept of sustainable agriculture and environment. We aim to provide a platform for researchers and academics, as well as practicing professionals from all over the world to present the research and professional development activity in agriculture, environment, food, and another relevant subject, such as immunomodulator again to COVID-19. Finally, on behalf of Universities Plus Maret, I would like to thank all partner, university, invited speaker, participant, and invited guests who support this conference. I also congratulate and appreciate the organizer for the great effort to make this online conference successfully organized. To all participants, I wish all of you have a very fruitful, dynamic, and constructive conference and also great discussion. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you so much for Professor Ahmad Yunus for the interesting speech. I can guarantee that everyone here cannot wait to start the session. But before that, let us read some rules for the participants during the session. So participants are expected to follow the event in conducive manner. For the participants have to mute the audio as long as the speaker delivers the session. And if you want to be on camera, you should be in a polite position. And for the question and answer session, all the participants can ask questions through the chat box. You can ask there with the format your name and then institution and then your question.
Yes, please, for all participants, remember and follow all of the rules during the session. Okay, for the first session will be great by our moderator, Dr. Andriana Setiawati from Universitas 11 Maret. So without any further ado, please welcome Dr. Andriana Setiawati.
Thank you very much for Mr. and Mrs. MC have been introduced me as a moderator. Good morning. Assalamualaikum warahmatullahi wabarakatuh. The Honorable all of the invited speaker and the Honorable distinguished guests and all of participants. First of all, I would like to welcome you all to the 7th International Conference on Sustainable Agriculture and Environment, which is held by Universitas 11 Maret. In this session 1, we shall have outstanding presentation from Prof. Henry Utama and Prof. Ahmad Yunus. They are our prominent presenter, whom I believe shall enrich our insight and knowledge regarding the theme of this seminar. In this morning, we shall have parallel presentations, so if you have a question for the speaker, could you please use Zoom room chat, and we will keep your question, then we will discuss it later in the Q&A session. Before the presentation begins, allow me to introduce all of the speakers. Our first speaker is Prof. Henry Utama from Louisiana State University, USA. His major is plant biotechnology, and he is a professor at LSU at Center at Rose Cafe Race Research Station from 2018 until now. Then the second speaker is Prof. Ahmad Yunus from Universitas 11 Maret, Indonesia. His major is plant physiology and biotechnology. He is a vice rector of academic affairs, Universitas 11 Maret, and since 2019 until 2023. He is also professor at Faculty of Agriculture, Universitas 11 Maret, Indonesia, since 2009 until now. Okay, without further ado, I would like to welcome our first presenter, Prof. Henry Utama. Hello, Prof.
Hello, moderator. Thank you.
Good morning, Prof. Henry.
Good morning. How are you doing?
I'm sorry, your speaker. Okay, you have 25 minutes for presentation, Prof. Please, time is yours.
Okay. First of all, I would like to apologize that I'm not able to give live presentation due to a prior commitment in different webinar that taking place at exact same time. However, my colleague, Professor Winifrida, who has a similar academic background with me and expertise as well, I'm happy to serve as a speaker to share my knowledge in agriculture, especially in smart farming and sustainable agriculture. I would like to thank Bapak Rektor Universitas 11 Maret, Profesor Jamal Wibowo, Bapak Vice Rector 1, Professor Dr. Ahmad Yunus, a good friend of mine, and to the committee of the 7th International Conference on Sustainable Agriculture and Environment for inviting me. Many times, especially in Indonesia, very often we hear a word sustainable. It is not only used in agriculture, but also in many other areas and it is almost overused, I would say. In agriculture, when the word sustainable is used, it is commonly associated with environment, and there is tendency to lean toward conserving environment. The fact, however, that the meaning of sustainable is much more than that. So, with that, I would like to explore all the detail in my presentation. Let me share my screen now with you. Just be patient. I'm sharing my screen now. Just a second. All right. Okay, the title of my presentation today is Smart Farming, Key to Sustainable Food Production. This is just a reminder for you who are already familiar with this term, that sustainable agriculture is an integrated system of agriculture production practice that first fulfill our need of food and fiber, make the most efficient use of non-renewable resources, enhance the quality of life, enhance the environmental quality, and enhance natural resources where the agriculture depend on. These factors are equally important. So go back to my remark previously at the beginning of my presentation. We just cannot emphasize just to environment only. This is very important principle. Now we move on to the precision agriculture. It is the approach to farm management that uses information technology to ensure that the crop and soil receive exactly what they need to be, no more and no less, which is precise. The goal of agricultural precision is to ensure profitability, sustainability, and protection of the environment. For that, protection of the environment becomes important consideration as well. With the precision, there will be no excess of chemical leaching out to soil and water, for example. There will be no waste, and there will be saving money, reduced costs, and as a result, environment is protected as well. If our environment is not protected, the soil becomes less productive, causing lower profit, and also costs to our health and become jeopardized. In this slide, in the recent years, investors has put more than $250 billion into the tool and system. Among the big one, the precision agriculture will concentrate on precision fertilization, precision planting, precision in irrigation, and compaction reduction. So this is among the big force spender over there. Let's talk about the smart farming. Smart farming is a management concept to provide agriculture with advanced technologies such as big data, Internet of Things, and artificial intelligence, just to name a few. Making agriculture smart in monitoring, tracking, automating, and analyzing operations. This will help solve issues of smart farming can tackle the most demanding world issue with exploding population to 9.6 billion in 2050. This figure shows the interconnecting components of smart farming. It is rather complex, I have to admit. The goal of smart farming is not on precision measurement or determining differences within the field or between individual animals, but it is focused on how collectively information collected can be used in a smart way. Smart farming include farm operation, not just individual. Let me go back to slide before. So smart farming include operation, not just individuals. Farmer can use mobile devices such as smartphones or tablet to access real-time data about the condition of soil and plant, terrain, climate, and so on. And because of that, farmer can make informed decisions based on accurate data rather than the intuition. So smart farming will deliver a more productive and sustainable agriculture production based on more precise and resource efficiency way. Figure on the left is the interconnected of software, telematics, cellular communication, sensing tech, data analysis, and hardware system. Complicated component that can be made user-friendly to make it easier to operate. And it is always an issue between big farmer versus small farmer, between rich and between the poor. But there are some large farms that are very successful, but there is also a management void in many of them. On the other hand, the smaller farmer will be more hands-on and do a job of managing each square foot than the big farmer. So there is enough room for everyone, as long as they are willing to get involved. As we progress, we start seeing now smart farming making impact on smart city. Smart farming is being integrated into smart city design and functionality. Let's just take a look at California. Less than 2% of Californians feed the 98% of its population. And the same people that working on that are also providing specialty items such as delicious strawberry, tasty almond, enchanted wine, which some of those items exported out of California to the world. This is very fascinating. And what is the reason for this success? The reason is that California farmers have embraced technology to increase yield and conserve water, energy, and land. How about developing country? This question, developing country who are typically smallholders and who are often make field decisions on the basis of intuition. These are changing too, so we will discuss just in a bit later. Now, where the third green revolution is coming, all of that is where the smart farming and Internet of Things agriculture will go to. It will drive agriculture and food production to the third green revolution. It is powered by combined application of data-driven analytics, technology, such as precision farming equipment, Internet of Things, big data, analytics, unmanned aerial vehicle, and robotic, and so on. Imagine by 2100, world population is predicted to grow to 11.2 billion of people. That is very colossal thing. We will need a food production and distribution to support additional of 3.6 billion people with a little of additional land and living as small as possible in environmental footprint in order to maintain vital ecosystem services and conserve Earth remaining wildlife. This is really big challenge for us. This is the predicted 11.2 billion people by 2010, just the median now. at the middle part, the mean of the prediction. As we all know that the availability of land is very much the same. How can we produce more food, much more food? We know that 70% of Earth's surface is ocean and water. Only 29 is land. Out of that 29%, 71% of it is habitable. 50% of that for agriculture, which is approximately 51 million square kilometer, and within that 77% for livestock and only 23% for crop. So it's very, very small portion of Earth. How can we manage to produce more food? This is a big question. So this is one hopeful thing that we know now. This is one thing that we know based on some research. The urban can grow more efficient, time efficient per square meter where compared to rural region. We can go vertical to increase efficiency to be more than 10% at 10 times higher than normal. And this is just the beginning. And it is then, if this then continues, we can meet the century challenges on food production. We can also, the developing world can also take part. Look at the impact of agriculture precision on developing world. Started with Africa here. This is the simple equipment for harvesting tea leaves, precise and economical. And also in many other countries, in India, for example, Indian IT-based precision agriculture, where the information and data driven for better decision-making and reduce the risk of uncertainty commonly associated with the agriculture can be tackled. Startups such as Setsure, Propline Technology, Gold Farm, and so on are investing in technologies and managing solutions to help farmers across India. So India is also moving ahead with other programs, taking advantage of mobile technology that is adopted well, just like here in Indonesia. So satellite technology and its application are being used for next level for transforming India's agriculture. Automated farm edge detection, for example, in the left side of the slide, and automated crop classification on the right side of the slide. This is something interesting, and it's not stopped there. It is moving to making the practical application of farming and become more accurate and controlled. For example, pixel by pixel time series trend analysis or automated crop health monitoring. This is component of precision agriculture. There. Okay. So the possibility is endless for developing country, and hopefully Indonesia can also jump in the same bandwagon. Here, now let's take a look at what does it take to be involved in these new trends. We do not need to build new university for this. Let's learn from Europe and America. In Europe, partnership among competent universities can be used to build smart agriculture up and running immediately. As an example here, institutions such as ICSAE-7th from France, UTED, Portugal, NWBU, and so on from Norway get together to form the most advanced farming partner university to support the industry. The collaboration is based on specialization. UTED Portugal, for example, is specialist in GIS, teledetecting, and e-learning. And MBU Norway, for example, focus on particularly on robotics and their application in crop. University of Helsinki is on automation system, technology, and modeling applied to northern crop system. And here, the critical group of program crucial to smart farming include precision agriculture, sensor technology, data analysis and modeler, geomatics and remote control sensing, also automation and mechanics, and also robotics. The US has a different approach. University advances a certain program or department in their university to advance technology needed. For example, here is University of Nebraska, Purdue University, Iowa State, Ohio State University, UC Davis. As we can see here that the departments are overlapping, not limited to agriculture per se, but it can be with the College of Engineering, Biological System, Biological Engineering, and so on. The outside top program include University of Sydney in Australia and Massey University in New Zealand. As we can see, urban farming is also part of the growing university program in here. This is one of the examples, the program in University of Oregon. Now, with this new trend, new student and new breed of agricultural student will have completely different set of mind and education. When compared to conventional agriculture, more exciting to fulfill different role interchangeably with different interdisciplines. These are students at the Berkeley Food Institute in UC Berkeley. University can also set up startup incubators. These are an example of urban farming startup that make a great impact on smart city. There are City Farm, which is vertical farming, Sky Vegetable or rooftop farming, that develop and operate urban hydroponic rooftop farming, producing green and greenhouse throughout the year. The Alexa Live technology, turnkey free container farming, is a combination of smart urban farming and hydroponic crop monitoring software and light emitting diode, LED light, allowing citizens to densely pack plant and crop into free container. This is smart idea. The next one is smart Internet of Things based on smart farming. Their solution measure humidity, air and water temperature, carbon dioxide level, and so on. And the data is accessible on both mobile and web applications. The next example is Aqua Pioneers, an urban aquaponics, that develop aquaculture kits, which transform a 54-liter aquarium into an aquaponic ecosystem to grow food all year round in household, office, or co-working space, school, and hotel. This is really interesting development. And now, let me close my presentation with this. We have an old statement, agriculture is interesting. It is about nyangkul, that's local people say. But it doesn't to be that way. With this new trend, agriculture students can involve in developing agriculture robotics or agriculture artificial intelligence or software developer and so on. It's not merely just like 50 or 50 years ago, which doesn't change that much. So we need to change that. And here we can see that student system for biotechnology Internet of Things and big data analysis, and also artificial intelligence to develop non-toxic agriculture disease and fertilizer regulation system, which is called AgriTalk Management Performance. So this is several example and how we change the agriculture and the image, old-time image that we have. Again, the new student can also learning sensor technology, data analysis and modeling, and also geomatics and remote sensing, automation and mechanics, and also robotics. It's a very fast discipline, and agriculture student can move in and out and change and also have the background science in fastly as possible. So with that, and if anyone has the question, Dr. Benefrida, Professor Benefrida will be able to answer your question. Thank you and good afternoon.
Okay, thank you very much, Prof. Harry. That is our presentation. It's about smart farming, key to sustainable food production, which is smart farming is a management concept to provide the agriculture industry with the support of advanced technology such as big data, IoT, and then so on. And this technology make the agriculture industry smart by assisting the monitoring, tracking, and then automating and analyzing operation. That is very interesting. So let's move to the next presenter. So let me inform you again for all the participants who have a question. Please use Zoom room chat, and then we will discuss it later in the question and answer session. Okay, so let's move to the next presenter. We will have a Professor Ahmad Yunus, with the topic is about natural resources for prevent the COVID-19. Without further ado, let's welcome our second presenter. So, hello, Prof. Yunus.
Hello, Mrs. Andriana. Good morning.
Thank you. Good morning. Thank you very much. This morning you can join with us, and you have a 25-minute, Prof. So, without further ado, so please, time is yours.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Good morning, Professor Heri Utamo, our closely partner for several years. And good morning for all participants. And we are thanks special for Master Mita Direk who organized this conference, always together with us since 2013. The first conference is held in Solo, the second is in Turkey, and the third is in Poland, fourth is in Turkey again, and four is in Solo, and five is in Tunisia, six in Turkey, and seven in Solo again, but by virtual. Okay, let's screen our file. Yeah. So we will present about our contribution researcher in University of 11 Maret to supporting the control and break of pandemic COVID in this year, because as we know that this COVID-19 is spread in over the world, and we don't have the vaccine or the effective drug for beat this virus. Let me explain about the UNS innovation in food and pharmaceutical product. The first is we uh, accelerate the research in cacao to make the any food processing until go to industry. We collaborate with the Ghent University in Belgium and the Department of Food Technology in UNS. And the second is we make the peanuts and like peanuts to make the food from the peanuts and another seed we call koro, yeah, koro benguk, and extra in the source for the Java island. And special for the medicinal plant, we have also work in the immunomodulator plant. For example, is Echinacea purpurea. We increase the content of the echinacea with the make the stress, including the stress, drought stress, nutrition stress, and the temperature stress to make the better and higher the content of echinacea. Also for the we call the pegagan, we make the stress to increase the content of the secondary metabolite. And some students also research in the seaweed, for example, is red algae, to make the production of lectin is more and more in the one mass of the algae, red algae. And for the another product like oil, yeah, from eucalyptus, from nyamplung, from spirulina, and antioxidant also. And yeah, so our research now is still going to diagnosis the Apium graveolens in Indonesia is seledri, tanaman seledri, to make the well-functioning immune system on pregnancy to protect against COVID-19 infection. Preliminary study, we extract the leaf of graveolens, Apium graveolens, and we give the extract to the mouse. In this research, we will study about the effect of celery, because the celery has effect on the hormonal system, that is follicle stimulating hormone, to stabilize or to keep the FSH will affect the to increase or stabilize the progesterone induced blocking factor. This hormone is have in the woman who pregnant. The progesterone induced blocking factor is to maintain the pregnancy of the woman. Yeah. So another research is we have effort to make the more production for the aromatic rice by the radiation breeding, and in the 5 level of radiation of the Phileas or heritability fifth, we have candidate to a new variety with the particle density index and uh, productive plant more than the control. That is from Mentik Wangi and Mentik Susu. I think this candidate will be released by the Ministry of Agriculture. And another feed, UNS also try to product several medical prevention to hospital doctor and also to uh, people. For example, we already success in the make of face shield, the disinfectant chamber, full face protector, hand sanitizer, incubation box, portable ventilator, and also automatic ventilator. So now is in the clinical test from the Ministry of Health. And also for the COVID-19 rapid sensor based on potentiostat and contactless thermometer measurement and robotic assistant nurse for hospitality and contactless waste travel and simple thermogun. So because the bioactive compound in medicinal plant as inhibitor for especially for main protease virus SARS-CoV 2, and also the bioactive compound is contain the antiviral and also as immunomodulator. For example, this medicinal plant is Curcuma longa, Zingiber officinale, virgin coconut oil, Apium graveolens. And contribution of UNS to research in relative to the control of COVID-19 is the effectivity of Apium graveolens to protect the COVID-19 and analysis nucleotide SARS-CoV 2 strain Java and analysis of cytokine expression and cytolytic natural killer for the COVID-19 patient. And also for therapies, there are some research team for plasmapheresis. There is the therapeutic innovation for acute respiratory distress syndrome. And also the effect of curcumin and gingerol plus VCO to cytokine pro-inflammation and activation of NK cell for the COVID-19 patient. And some of the research for the COVID-19 is also in the robotic and ventilator, and also for the humaniora, for example, the self-sufficient in the level of RT, ya, rukun tetangga and rukun warga, in the implementation in PSBB to strict the spreading of the COVID-19. And also the mathematics model to predict the spreading of COVID-19 in Indonesia. and also for exploration pandemic COVID-19 from the Javanese culture, and community empowerment for management and rehabilitation of COVID-19, profiling the psychologist risk pandemic COVID-19 based on the social economic of the population in the province. And this is the interesting because the tradition to give the drug for the pandemic disease by the Javanese culture in the ancient manuscript Serat Sentini in the 9th century. And the second batch for the research is the development of eucalyptus. That is still the research, because the bioactive of eucalyptus is inhibitor of the COVID-19 rate in our forest. This means Mount Bromo Special Forest area. And COVID-19 therapy with natural herbal nebulizer synergy method and oxygen relaxation agent. Local development adaptive model for creative industry and realizing resilience of tourism village. Social engineering legal and health protection by the local government against creative economy business, and an effective legal disciplinary model to protect informal worker community toward a new normal era, the effect of psycho-education and relaxation, psychotherapy on stress level, interleukin-6, serum cortisol level, and COVID-19 patient recovery. And also the end of this topic of thema is integrated flag time model in optimizing public service of local government in the new normal. So in the overall research program in UNS to break and block the spread of COVID-19 is the preventive, the curative, and the end of this program is rehabilitative. This is all of our program in UNS to control the COVID-19 pandemic. Okay, thank you very much. And we are also thanks to Dr. Mithat from Selçuk University, Turkey, Professor Heri Utomo, and Professor Ida Hanarida from Louisiana State University, and Professor Taifu Mahmud from Oregon State University, Dr. Krista Jacobsen from University of Kentucky, and Dr. Halis Simsek from North Dakota State University, and also from Professor Pao Sanchen from Guangxi University. Thank you.
Okay, thank you very much, Prof. Yunus. It was a very interesting presentation that particularly about the UNS innovation initiative to prevent COVID-19, and then you explain how UNS that prevents COVID-19 and to avoid COVID-19 maybe also, and also that interesting is that you was research the celery Apium graveolens that can affect in COVID-19. Is it true? So all of the panelists in this session 1 have presented their insight, and there is knowledge for us, and I believe it will be increase our insights. So we have arrived in question and answer. For all the panelists, maybe I have a question. One is for Prof. Heri and another is for Professor Ahmad Yunus. Okay, my question is to Prof. Heri. In the USA, how productive are urban farming? As we know, maybe in Indonesia is smart farming a little bit news. I mean, news is we don't have used to in smart farming, so we still like a manual or still out farming. So maybe I would like to know how productive are urban farming in the USA.
Well,
And okay.
Productivity, thank you for the question, is real good. So it's control environment and also using the technologies that fit into that system. Adoption itself, however, is not widespread. It is high investment in here because this is that's why it's very famous among the good restaurant. So it's not really yet into making the big impact on the regular markets, but some of them start doing that. So the production of bok choy, for example, and then some of the vegetable that for food, special food is also very famous in here. So I think the prospect is real good and really good because you can kind of build up vertically as high as you can, as much as your fund available, and the production can be controlled real well and is free of disease, organic plant for sure, because it's no pesticide applied and so on. So it's very interesting thing to watch. And they are very creative to create something new, like the use of the trailer box. There's for the transportation of 18-wheeler or something like that. There's a lot in here unused, and they switch that boxes, like container boxes, into the growing chamber, and they can stack it up 2 or 3 higher than one box. So it's making potential implication there. And interestingly enough, all the electronic equipment for like irrigation system, which can be controlled automatically and or maybe remotely by internet, it can be is relatively affordable here. So I myself also working on that, try to see if this is good for just regular household like everybody else. So I'm trying to prove the concept. Hopefully it will work for just regular people like us. So I think the prospects are really good.
That's interesting. So maybe we should adopt the technology from the USA maybe, because compared with Indonesia, we still have a manual farming. So for the farmer, it's still news to use, for example, drone or maybe internet for the farming. So we still need time to make advance our farming, maybe, Prof. So
yeah.
Thank you for your knowledge.
I think this is what my take on it. I mean, we cannot just kind of throw it to the farmer. We need to build ourselves, to make our students interested in agriculture. So doing so, like maybe introduce the robotic technology, the coding, or software development and so on, and maybe join with the agriculture engineering or full engineering, or maybe software company. So the facultas need to outline a program that is allowing new students to have a different point of view about agriculture. And then using that technology that students acquire from the university lecturer or program, and then the farmer can be benefit to it. So we cannot just throw it to the farmer, but we just need to start it with the university. Like I give you an example there that we don't need to create something new, but maybe just to assemble it from different departments around the university. It can be in ITB, ITB, or Gama, or anywhere else. Just pick something that they could and make it precision agriculture or smart farming or anything like that, or the future of agriculture or anything program that can be entice students to learn more difficult thing and to relate to that expertise, and also allowing them to jump over to different career. So the student from agriculture can be like student changing major to become a doctor because of that, or become engineer in robot, or become software developer. So it's interchangeable. And this will benefit the agriculture to build it from scratch, but we need just to assemble the right mind, the right system, the right specification or specialization that already we have it here in there. But we need just to collectively put together, assemble it into a big system. This is what we do here in the US.
Okay, that's great, and I agree with you, Prof, that as a researcher in the university, we should prepare our students to be a smart, ready to face the smart farming in the future. I agree with you. So maybe my question for me, Prof. Yunus, how effective is salary for COVID-19, Prof? So it is very now is very interesting topic about COVID-19. So how effective in the salary for COVID-19, and can you explain more deeply about the recent study about the salary?
Okay, maybe I will ask the Dr. Revi to help me to answer. The principle is the salary have the effect for the hormonal system, to stabilize the hormonal system. Yeah, and the hormonal system is we call FSH, follicle stimulating hormone. Yeah, follicle stimulating hormone actively and prevent fetal resorption caused by NK cells transfer. And thus the progesterone-induced blocking factor plays an important immunoregulatory role in the pregnancy success. This is special for the woman. Yeah. And celery was chosen as a potential medicinal candidate because in the additional above benefit, celery has also shown to an effective on hormonal system to make the stabilize, and namely that a certain doses it can affect the increase and decrease the follicle stimulating hormone or FSH. Luteinizing hormone, ya LH, ya luteinizing hormone or LH. This is the hormone who affected by the follicle stimulating hormone. The change in the FSH will affect other hormone mechanisms such as progesterone, where the progesterone-induced blocking factor is a progesterone mediator that inhibited NK cell. That is the mechanism and the function of the extract of celery, the extract of overall extract.
Okay. Yeah. Okay, that's very interesting, Prof. Maybe
because,
I will ask to, yeah?
Pardon, because now is still doing research. We don't yet the analysis the progesterone induced blocking factor. Maybe next week we analyze the content of progesterone induced blocking factor. If the effect of celery extract can the maintain or increase the progesterone induced blocking factor is proven, that is the new innovation for our science in the cell 3. Thank you.
Okay, thank you. We will wait your good news from the celery. Hopefully it will be effective to prevent COVID-19. So it will be good news to our. So maybe from Prof. Harry, do you have any comment to the COVID-19? Maybe as for example, in now it's very popular about the COVID-19. So in USA, maybe urban farming. How urban farming facing the COVID-19 in the USA?
That's a great question. So during the COVID-19, I saw the activity of farming, urban farming is exploding because not many people can go out of the house, so they do anything that relaxing, and they turn into urban farming. So the sales of the farming kits is also rising really fast. So I saw it is a good positive thing, and people look into their inner interest that that before never been think that way because they don't have time to think about it. And now they do, and since they have plenty of time, they try to relax themselves or doing something that probably worthwhile. So they try the urban farming. I see the urban farming activity increases.
Okay, thank you, Prof. Okay, no. For the information maybe to the audience, we received so many questions now, Prof. So all of the panelists already present their theme. So it's time for the audience to ask you a question. So maybe it will be limited time. So our committee have been selected several questions, and it is addressed to every panelist. So there is question from the audience for Prof. Harry and Prof. Yunus. For the first question is coming from no name, okay, to Prof. Harry. According to there is two questions. First question is according to your impression, what are the obstacles for Indonesian to jump to the smart farming system? That's the first question. And then the second question is, the more agriculture activities tend to reduce the genetic diversity of many plants as well as the animal resources. What needs to be considered to keep or protect the genetic diversity in this regard? Okay. So, please, your answer, Prof. Harry.
Okay, the first one is that I don't think there is any handicap or any problem adopting the smart farming in Indonesia. Let's take a look at the India or other countries. They naturally move technology like information and mobile cell phone and use them as a way to create one of the for smart farming. So we need to do something like that. Like I said before, I think the university will need to decide or to design something that allowing the smart farming to be adopted first at the university level or student level or curriculum level. And from there, you will get the expertise and so on. You get environment, student, and faculty talking about the smart farming all the time and create something that that may be necessary to how to solve the problem in Indonesia. I think this is very local problem, and in general there will be a common rule for smart farming, and everybody can learn from anybody else in the world and adopt that farming into their own local need, because it has to serve in local need. Like here, maybe the strawberry is very important, crucial. So the smart farming concentrated on strawberry or in pecan or anything like that. But over there, you have to identify what is needed locally, and you have to develop a system. I think it's not that difficult to do the production in terms of smart farming principle there. So I think by creating like climate or environment in a way that student, faculty, professor, and student, and also the like the industry and also business person, company, to get together to develop something that that is very efficient. I'm sure it will be, because all the equipment is already available somewhere, like the monitoring the temperature, the controlling irrigation system, everything is already in the market. We just need to assemble that and put it all together, and then of course you have to correct it to the according to the local environment and local weather and stuff like that, and also maybe the custom or how society reacted to it. But this is something that Indonesia has to be on its own. But the basic principle is remain the same in India, in Africa, or in the United States. They are the same. You just need to build the second question was, genetic diversity. I think there is nothing wrong with the agriculture activity that we do now. I mean, as long as there is a gene bank, seed bank, or maybe company who is dealing with the seed and material. Here in US, we have like US Gene Bank or US Seed Bank, where we can ask the seed to be distributed and so on. So there is no, and a certain particular area, if we are afraid of there is some degradation in genetic diversity, is allocated for like a natural habitat that nobody can do anything with it. Here is very common, so there is a zonation of the region where no agriculture permitted, no house permitted, so let it go naturally like that. And more important too, that the diversity is maintained by certain organization or government branch that deal with the seed and diversity itself. So we do have a collection of worldwide seed from different countries that we have in our national depository. So if you are afraid of that, if Indonesia is concerned about that, Indonesia can maybe have the branch of government who deal with that. I think it's very common, and the germplasm can be maintained, and with the science and the agriculture production, actually the diversity can be improved as well, because every hobbyist, every farmer has their own seed and maybe have different tastes and so on, that they prefer to something different. We do have the hobbyists in here around in the US who exchange the seed from one person to the other person. This is legal because this is encouraged, because this is hobby, and everybody has their own seed and likeness for certain type of plant or vegetable that they like very much, they keep it. So if we can do that, so the citizen will be responsible for maintaining diversity because of their hobbies, not because of they asked to or somebody told to do it, but because of they like to do it. So I think the education factor, the student and the university has a lot of role to play. So they get together with NGO. And if you have time, you can erect or you can build NGO for that, and it's very common also in here. So, for example, me as a professor, I have several NGO with different activity. So it's kind of hobby, but it's also useful for agriculture and society as well. We do have the organic NGO. We do have the slow grow or slow cook NGO. So everything is dedicated to our hobbies, but in terms of managing something authentic and diverse is part of the goal.
Okay, thank you very much for your great answer, Prof. Then, next question is for addressed to Prof. Yunus. How to assess the result of study from UNS, especially with regard to the research linked to COVID-19? Please, your answer, Prof.
Yeah. Okay, we collaborate with the Ministry of Research and Technology, Kemenristek, because we are the member of the National Consortium of COVID-19 research. And maybe the budget of the, not of the third, but the fifth, the budget of the research in the COVID-19 is obtained by the UNS. We have a big team enough to research this several subjects, from agriculture, from chemistry, from health, from the social science together, and also for the forest scientists together to make together to research that is contribution to the break or control the COVID-19. And the first step I think we obtained until maybe 10 million from the government for this year.
Okay. Thank you very much, Prof. Yunus, as your answer. Okay, finally, all the questions have been answered by all the panelists. Thank you very much, Prof. Heri and Prof. Yunus.
You're welcome.
Your great presentation. Okay, thank you. Unfortunately, because of limited time, so we have to end our discussion in this session 1 today. So thank you very much, Prof. Heri, Prof. Yunus. It has been a great discussion. Okay, thank you very much.
Thank you.
I apologize.
Thank you, Prof. Heri.
Thank you, Prof. Yunus.
Okay. I apologize if during session 1 there is a mistake or a conditional thing. So let me give back the time to the MC. Thank you very much. Assalamualaikum.
Thank you so much for the insightful session. It was really nice to have the speakers there. And as we know that they have presented some researches such as smart farming and then the challenges in the developing countries and then the use of precision agriculture and then the researches of the COVID-19. That was really great. I really hope that they can develop and they can spread it in Indonesia.
Yes, I agree with you, Vero. The season is really insightful, such as smart farming that can deliver more productivity in agriculture and how beneficial net agriculture for pandemic COVID-19. Okay, for the next session, before we go for the next session, we would like to inform the participant again to mute the microphone or audio, and if you want to turn on your video, please in polite position. For Q&A session, you can deliver your question at Zoom chat box or live stream chat box with format name underscore institution underscore your question.
Okay, cool. So let us move to the next session. There will be Dr. Prabang Setyono as our moderator. He is a lecturer in the Faculty of Mathematics and Natural Sciences in Universitas 11 Maret, Indonesia. So we won't have to wait so long. Please welcome Dr. Prabang Setyono. Hello, Dr. Prabang. You hear me?
Halo Mas.
Okay. Okay, cool. How are you doing? I can't hear his voice. Okay then. Okay, Dr. Prabang, maybe
Maybe.
sorry.
Yeah.
Okay, cool. Hey, Dr. Prabang. How are you?
I'm fine.
Okay.
I'm
Okay,
fine.
cool. Okay. Okay. Without any further ado, let us present your presentation. So, Dr. Prabang, the stage is yours now.
Ladies and gentlemen, welcome to this seminar on International Conference on Sustainable Agriculture and Environment, plenary session. The two invited Mahmud from USD. From the Universitas 11 Maret. Let me introduce myself is Prabang, and I will moderator the first. I would like to thank you to organizing committee, steering committee, the our president. Thank you for this. Before we start the presentation.
Bahan saya udah di sini ya.
The first session, speaker has time about 20 minutes, and next the rest of time. And now, the first I would like to invite Professor Taito Mahfud to presentation this presentation. The CV, curriculum vitae, the Professor Taifo Mahmud. Professor Taifo Mahmud come from Oregon State University, USA. Professor Taifo Mahmud, expert the natural product chemistry, Professor Department of Pharmaceutical Science, Oregon State University, USA. And the second speaker, Betty Suryawati. Dr. Betty Suryawati come from Universitas 11 Maret, the expert biomedical science, lecturer Faculty of Medicine, Universitas 11 Maret in Indonesia. Okay. First, I would like to invite Professor Taito Mahmud, time of yours in 20 minutes. Okay, Professor Taito Mahmud.
Right. Thank you very much, Mr. Moderator. Assalamualaikum warahmatullahi wabarakatuh. First of all, selamat pagi and salam sejahtera for all of us. First of all, I would like to thank the organizing committee, Professor Ahmad Yunus, for inviting me to talk in this symposium. Allow me to share my slides. Right, so today I will be talking about green controls for plant pathogens. So as mentioned just now, I'm from Oregon State University. Just briefly about Oregon State University. So it is a public university located in the Willamette Valley of Oregon, in the foothill of the Oregon Coastal Range. It is a land-grant university, but it is also designated as a Sea Grant, Space Grant, and Sun Grant institution, making it one of the only 4 U.S. institutions to obtain all 4 designation. So when Linus Pauling received his BS degree from Oregon State University in 1922, the university was still called the Oregon State Agricultural College. So although I'm with the Department of Pharmaceutical Sciences and my research focuses on drug discovery, the environment here has been very good for me to work on finding drugs to treat plant diseases as well. And I'm also blessed to have a number of very capable collaborators here at OSU. I've been collaborating with Jeff Cheng and Melody Putnam from the Department of Botany, Plant Pathology, working on finding controls for bacterial infection caused by Agrobacterium and Rhodococcus in nursery plants. And this project was funded by USDA National Institute of Food and Agriculture. And more recently, we also received funding from NSF and USDA until 2024. And also very recently, I've been collaborating with Jeremiah Dang, also from the Botany Plant Pathology Department here at OSU, on managing bacterial blights of carrots. So this project has also been funded by USDA NIFA until 2024. So, but today I would like to talk about mainly on managing diseases caused by Agrobacterium, tumefaciens, and phytopathogenic Rhodococcus in the nursery industry. At the end of my talk, I will talk about another class of compound, antifungal agent that being used to treat rice plant. But now let me start with floriculture, which is a significant sector of US agriculture. And floriculture and nursery crops are the 3rd largest US domestic crop in value, only behind corn and soybean. The industry is worth $36 billion in retail. Unfortunately, sometimes losses due to bacterial infection are very high, amounted to many millions of dollars annually. And Agrobacterium tumefaciens and Rhodococcus are 2 groups of broad host range gall-forming bacterial pathogen that cause those losses. So Agrobacterium tumefaciens, which can cause crown gall, is particularly notorious because it can cause up to 40% reduction in yield and vigors in some perennial plants. It can infect almost 100 families of herbaceous and woody dicots, but there are no universally effective preventive measures and no cures for infected plants. Rhodococcus faciens, on the other hand, can cause leafy galls and other deformation, and it can infect more than 120 species of plant. It is an emerging threat to the nursery industry, and there are also no effective preventive measure and no cure for infected plants. So initially, the pathogen colonized plant epiphytically, and it is hypothesized that a plant metabolite triggers the bacteria to produce an autoregulation or autoregulatory compound that initiate a signal transduction pathway leading to the production of virulent factor. Therefore, one of the objectives of this project is to discover environmentally friendly green controls to manage diseases caused by Agrobacterium tumefaciens and Rhodococcus in the nursery industry. And speaking about virulent factors, we were intrigued with a paper published in 2011 reporting the discovery of a compound called perbergin that can be used as a virulent quencher of Rhodococcus. This compound was isolated from the bark of the Malagasy legume Dalbergia pervili. Perbergin protects the plant from deformation caused by Rhodococcus faciens. So at a low concentration, it inhibits the induction of bacterial virulent gene expression and function as a virulent quencher. So we thought, we wanted to isolate and test this compound, but the problem was the plant is found only in Madagascar, which we didn't have access to. So we decided to develop a synthetic strategy to make the compound chemically. And long story short, we were able to make the compound from this benzaldehyde and then this 3-hydroxy acetophenone in 9 steps. And we were able to obtain the compounds based on the reported structure of perbergin and then its isomer here. And indeed, both of them are active against Rhodococcus faciens, as well as against Mycobacterium smegmatis and Staphylococcus aureus. But they are not active against the gram-negative Pseudomonas aeruginosa and E. coli. Presumably, we believe the geranyl side chains appear to be important for the activity because compound that doesn't have the geranyl side chain was inactive. And interestingly, we found that the NMR data for our synthetic compounds are different from those reported in the literature. So that pushed us to reanalyze the 1D, one-dimensional and two-dimensional NMR spectra of the published compound. And based on that, we concluded that the published chemical structure of perbergin was wrong or incorrectly assigned. That led to the revision of the chemical structure of perbergin that we published several years ago. Next, as part of our effort to find green solution to control Agrobacterium and Rhodococcus infections in nursery plants, we investigated a number of herbs that have been reported to have antibacterial activities, such as yarrow, wormwood, cornflower, chamomile, dandelion, and ashwagandha. And we found that extract of 5 of these plants were active against rhodococcus, particularly the ethyl acetate extract of ashwagandha, which is known as Indian ginseng or winter cherry. And through bioassay guided separation and purification, we identified that withaferin A is the active component of the ashwagandha extract that inhibit the growth of Rhodococcus faciens. It is a steroidal lactone with interesting structural feature. Also, in collaboration with Professor Katsuyoshi Matsunami from Hiroshima University, we also screened several hundreds of extract of plants that his lab prepared. We found a number of them were active against Agrobacterium or Rhodococcus, and one of them was Strobilanthes cusia, which is known as Chinese rain bell or Assam indigo. And through bioassay guided separation and purification, we found that tryptanthrene is the compound that is active in the extract that inhibit the growth of Rhodococcus faciens. It turns out that this type of indoloquinazolone alkaloid can be easily synthesized chemically. Therefore, we launched a medicinal chemistry campaign to synthesize various analogs of tryptanthrene, and we'll screen them for anti-Rhodococcus activity. So we also collaborate with Dr. Noviani at Lampung University, and we screen some natural compounds from the Indonesian plant Sesbania grandiflora. This plant is locally known as turi and is frequently used as traditional herb medicines to treat diabetes, cough, urinary diseases, infection, etc. While the natural product did not show any strong activity against Rhodococcus, one of the derivatives that we synthesized in the lab showed respectable anti-Rhodococcus activity. This work was published recently in Phytochemistry Letter and Journal Natural Medicine. And this is Dr. Noviani when she visited our lab a couple of years ago. So while working on a Rhodococcus culture, a postdoc in Dr. Jeff Chang's lab discovered that her plate was contaminated with another bacterium. Interestingly, she found that the contaminant produced something that diffused into the agar and killed Rhodococcus. After complete genome sequencing, we discovered that the contaminant is a Bacillus species. Then we grew the Bacillus and tested them against Agrobacterium and Rhodococcus, and found that whatever compounds being produced can kill Agrobacterium and Rhodococcus, as shown by the inhibition zone in this picture. And Dr. Jeff Chang's lab also used root growth inhibition assay to see if the bacterium can prevent Rhodococcus infection in plant, and found that the bacillus can indeed prevent Rhodococcus infection in tobacco roots. So this is the negative control. The root grows normally. This is the plant infected by Rhodococcus faciens. So the root cannot grow very nicely, it's inhibited. And then this is the plant treated with Bacillus species, showing no problem, meaning Bacillus does not affect the plant. And then these others are plants that was infected with Rhodococcus, but then treated with the extract of the Bacillus, and showing that the extract is indeed active or can prevent the plant from Rhodococcus infection. So we decided to investigate the active compound produced by the Bacillus. We cultured the bacteria and performed chemical analysis using bioassay guided separation and purification followed by chemical structure elucidation by NMR, mass spec, etc., we discover a number of lipopeptide compounds that are active. So interestingly, the compound that inhibit the growth of rhodococcus, like surfactant here, is inactive against agrobacterium. On the other hand, plivastatin, which is active against agrobacterium, is inactive against rhodococcus. So apparently two different compounds that act separately in inhibiting the growth of agrobacterium and rhodococcus. So instead of using purified compound, we wanted to test it, to test if a partially purified extract would be good enough to control the disease. So we developed a method that can quickly obtain fractionated extract that contains the active compounds and test them against agrobacterium using a carrot dish assay. These are carrot discs that were infected with agrobacterium. You can see a lot of galls formed here. And this is the negative control with potassium phosphate buffer. There are no galls formed. And then this is the carrots that were infected with agrobacterium tumefaciens, then treated with extract. You can see there are no galls, or not much gall was formed. And this is the pre-treated carrot with the extract and then infected with agrobacterium tumefaciens. So they are the same. So this again showed that the extract, partially purified extract, are active to prevent gall formation by agrobacterium. So we also tested the extract in plants using tomato plants that were cut and infected with agrobacterium. You can see the gall formation here, but if you cut and then you add the extract and then infect it with agrobacterium and no gall formation, and then this is if the infection occurs first and then you treat it, still a small amount or small size of gall is formed, but is not as big as the control. And then we also tested a number of different strains of agrobacterium. In all cases, the control, of course, produce a lot of galls, and the one that is being treated, they do not produce gall that much. And when we tried this with chrysanthemum plants, the result is the same. This is the one that is not treated, and this is the one that is being treated. So let me switch gear quickly to another natural product called validomycin A, which has been used for many years to treat fungal infection in rice plant. This compound is produced by a soil bacterium called Streptomyces hygroscopicus. About 30 to 50,000 tons of validomycin A is produced in China annually. It is being used across Asia and other regions, so it plays an important role in food security. And there have been a lot of study on the biological activities of validomycin A. Commercially, it mostly is used to treat the sheet blight disease in rice plant caused by the fungus Rhizoctonia solani. In fungi, trehalose is used as an energy storage or energy source. Whenever needed, it will be hydrolyzed to make 2 molecules of glucose by this enzyme called trehalase through this transition state that we call oxocarbenium transition state. And validomycin A in the cell will be hydrolyzed to make validoxylamine A. And if you see the structure, is very similar to the oxocarbenium transition state. So validoxylamine A can bind to the enzyme very tightly and inhibit the activity of the enzyme, so the fungi or the fungus cannot produce glucose and they cannot grow. So if you look the chemical structure of validomycin A and validoxylamine A, they looks like sugar, but actually they are not sugar. So it is amazing how nature make such kind of compounds that you may wonder what for and also how they make them. So my lab has been working on the biosynthesis of validamycin A for many years now. Specifically, we look at how nature makes such unusual compounds. We have published many papers in this area. We look at the genes and the enzymes that are involved in the formation of validamycin A, and along the way, well, we investigated step by step the formation of this compound, and along the way, we found a number of enzymes that catalyze unusual reaction, for example. And we found that the cyclic molecule is derived from pseudoheptulose 7 phosphate, which is the intermediate of the pentose phosphate pathway. And this cyclization is catalyzed by a very unique enzyme called 2-epi-5-epi-baliolone synthase. And then this coupling reaction here also between these two cyclic compounds to make validoxylamine A is catalyzed by another new enzyme that we call pseudo-glycosyl transferases. So for those of you who are not familiar with this type of work, you may wonder why we would spend time on this type of research. So by knowing the detailed biosynthetic pathway to this compound, we were able to engineer the pathway or to use the enzyme to produce analogs of validamycin A that may be useful for other purposes. For example, some derivatives may function as an alternative source of the starting material of the anti-diabetic drug voglibos. So we have published this work, and then we also got a patent approved for this work. And then we have also used some of the genes to make sunscreen compounds by mixing and matching genes from different sources, from bacteria, soil bacteria, or pathogenic bacteria, also from fish, to make the compounds that we call synthetic biology. This part of work has led to some publication as well, and then also some patent application, and has been was the basis for the formation of a startup company called Gadusol Laboratories. And my colleague in Shanghai Jiao Tong University has used this information to increase the production of validamycin A in the producing strain, which is of course beneficial for maintaining healthy rice production and important for food security. So in summary, I have mentioned that floriculture is a significant sector of U.S. agriculture, but losses due to agrobacterium and rhodococcus have amounted to many millions of dollars annually. And unfortunately, there are no universally effective preventive measure and no cure for infected plants. But we found that many plant secondary metabolites have antibacterial activity against agrobacterium and rhodococcus. We also found that bacillus have great potential for control agents to treat agrobacterium and rhodococcus infection. And I've talked about validamycin A, which plays an important role in food security. Its biosynthesis involves highly unusual enzyme and catalysis, and understanding it, biosynthesis have led to several technology development. So with that, I would like to thank the people who did the work, our collaborators and funding agency that support this research. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.
That is
Mr. Moderator, I cannot hear you at all.
I cannot hear. I'm sorry. Okay, you hear?
Yes.
Okay, thank you very much. A very interesting and inspiring presentation for
all of us about your innovation about the agrobacterium engineering. That was the presentation by Prof. Taifur Mahmud. Please give applause for him. Wow. Okay, now we move the second speaker. I please to Dr. Betty Suryawati, MSc PhD from the Universitas 11 Maret. Time is yours during 20 minutes also. Okay, Dr. Betty.
Thank you very much. Thank you for Mr. Prabang. And also thank you very much, Prof. Taifu, for the intriguing presentations. Good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to also say thank you to the committee for arranging this international conference on sustainable agriculture and environment. And also would like to thank all the audience for the participating in this conference this morning. First, I would like to introduce myself. I'm from the Clinical Microbiology Department, Faculty of Medicine at 11 Maret University, and also the Biomedical Laboratory 11 Maret University. And I'm currently also a member of 11 Maret University Academic Hospital Research, which is a part of the Indonesian Research Consortium for COVID-19. So now our project is on clinical trial on herbal medicine, curcumin as immunomodulators in COVID-19 treatment, and also we are doing SARS-CoV-2 genomic sequencing, especially from Java. Before we go to the herbal medicine, let's take a look at the coronavirus. So the SARS-CoV-2 is a single-strand RNA, the genome consisting 30,000 nucleotides, and this virus composed of 4 major structural proteins: the spike proteins, the membrane protein, nucleocapsid, and envelope. And the spike glycoprotein is very important to attach to the host angiotensin converting enzyme 2 receptor and plays important role in rapid human transmissions. And the M proteins plays role in this virus assembly, and the A and N proteins interfere with host immune system. Understanding the function and the structural and non-structural protein of this virus is very crucial for identifying the new drug target, developing candidate diagnostic tool, and the vaccines. And another thing about the SARS-CoV-2 is that this RNA viruses mutate over time, and these mutations can arise through a variety of different mechanisms. And such mutations can have major implications for the development of an effective treatment or preventive strategy against this virus. So, a study which analyzed about 12,000 SARS-CoV-2 genomic sequence from 28 different countries has detected 200 mutations, and even 130 mutations found the frequency of more than 10%. So the study also revealed that the different type of mutation in SARS-CoV-2, such as the S protein S614G type, saw higher fatality rates. So how about the Indonesian SARS-CoV-2 strains? So far, there were only 23 genomic sequencing of SARS-CoV-2 from Indonesia that have been submitted to GSAE. And of course, this is a very small number, and we need to provide more data about this because it is very important. And so part of the Indonesian Research Consortium, we are currently sequencing strain from Java, and hopefully the data can be available soon. And so far, all the Indonesian strain that has been analyzed similar to the other countries or the strain that's already submitted before, and more closely to the strain from China, and one is more close to the ones that in North America. Several mutations has been found in the sequence, but there is no significant change in the genetic compositions of SARS-CoV-2 spike glycoprotein genes and nucleocapsid protein. And even for the last 6 months, there were very extensive research about the virus and the COVID-19 disease, but there are many things still unknown, and including how actually the behavior of the virus and also how to treat the infection. Currently, there is no medications is recommended to treat COVID-19 and no cure is available. As of now, researchers are testing a variety of possible treatment. However, some of clinical studies shows that some of the treatment give adverse side effects to the patients, and these clinical findings indicate that it is important to seek alternative agents with effectiveness and have low toxicity to treat COVID-19 patients. Thus, it is important to explore alternative medicines such as herbal medicines to treat this disease. And then how does this herbal medicine play a role in the COVID-19 treatment? There are many types of herbal medicine that has been used from different cultures around the world, such as in Asian countries or in African countries. And people use this herbal medicine since quite long time ago to treat various of diseases. And WHO itself is encouraged research in alternative medicine, such as herbal medicine to treat this COVID-19 disease. However, the use of herbal medicine in COVID-19 treatment and prevention should be supported and be backed with scientific evidence, because otherwise it will put people in danger, because it may giving false sense of security and distracting them from the measurement that should be done to prevent the COVID-19, such as physical distancing, hand washing, etc. So, several herbal medicine have been studied, and some are still under research to see the effectiveness for this treatment. And one of the potential herbal medicine is curcumin. And curcumin is the phytochemical derived from the bulb of the plant Curcuma longa, and is the major component of turmeric. And based on the previous in vitro and preclinical study, curcumin showed potential effect as immunomodulator for COVID-19 patients. This table shows silico-molecular docking, which predicts the interaction between compound and some compounds and target protein SARS-CoV-2, the spike protein. And in this analysis, the compound curcumin was found to have the second lowest binding energy after the epigalactine galactosis green tea, and which means that has a binding affinity, high binding affinity to the spike protein in the coronavirus. And also in here, the docking position analysis also shows the amino acid within the S protein or the spike protein involved in the binding ligand, where curcumin forming a hydrogen bonds with spike protein at 6 amino acid sequence. In addition, previous in vitro study shows curcumin effect as antiviral compound. This table shows this picture shows the several antiviral mechanisms against various viruses. First, curcumin can attack the envelope of these several viruses, like influenza, avian flu, and then respiratory syncytial virus, and etc. And then curcumin also can regulate, inhibit the attachment of this virus as well. And then additionally, curcumin can regulate pro-viral effects by modulating the host cell signaling pathway. For instance, the NF-κB and other pro-inflammation cytokines. And curcumin also shows to inhibit viral replications, transcription and translations in Ebola, EBV, and HIV. So, understanding the potential role of curcumin in COVID-19, let's briefly discuss about the pathogenesis of the disease first. So, there are still many unresolved questions regarding the pathogenesis of this disease, and especially the reason underlying the extremely different clinical course, ranging from asymptomatic forms to severe manifestations. As most patients with COVID-19 exhibit no or mild to moderate symptoms, but 15% progress to severe pneumonia, and about 5% eventually develop acute respiratory distress syndrome or ARDS, and also multiple organ failure. And maybe in addition, people with no symptoms are still able to transmit the virus to other people. So coronavirus infection, including SARS-CoV, MERS-CoV, and also now SARS-CoV-2 infection can be fatal because of what is called by cytokine storm, which could lead to the lung failures. And targeting cytokine storm is considered as an essential strategy for coronavirus infections. These figures show the immunopathology of SARS-CoV-2 infections and the development of 19 ARDS, and where the potential maybe curcumin can do in this pathogenesis. So, for example, in this respiratory tract and the lungs, the virus enter the cell and then binding to the angiotensin converting enzyme 2 receptor. And this induces apoptosis and tissue injury, which then then release the chemokines which attract the cell PMN, monocyte, macrophages, and then dendritic cells. And they promote innate immune response by secreting alarmin and antiviral such as type 1 EFN, interferon, and also pro-inflammatory cytokines. However, the SARS-CoV-2 may evolve strategy to down-regulate the, for example, this type 1 EFN, which is very important for antiviral, and also it induces T-cell apoptosis. And in this process, the viral RNA and also other viral proteins has been recognized by, for example, this toll-like receptor and PIX-like receptors, and it will activate the transcription and release of pro-inflammatory mediators such as interleukin 1, interleukin 6, interleukin 18, tumor necrosis factor alpha. And these mediators which also can twist the functions of T cells and cytotoxic lymphocyte, which then secretes amount of cytokines too. So this forward law of the cytokines will result in the cytokine storms, can cause coagulopathy and also acute respiratory distress syndrome. So in here there are two mechanisms where it happens. First, using macrophage activations, which then cause hemophagocytic lymphocytosis or HLA, which is driven by EL1 beta, and also immune dysregulation driven by EL6, which cause then global immune. So common to cytokine storm syndromes introduced by loss negative regulations, because usually in the normal condition there is regulation, so negative positive regulation, but because of the loss negative regulations of the productions of inflammatory cytokines, that turn drive a positive feedback regulations and leading to exponentially growing inflammations and multi-organ failures. So this potential effect of curcumin against SARS-CoV-2 infections, first by targeting critical steps of virus replication cycle, such as viral attachment and also viral replications, and curcumin also inhibit inflammatory reactions such as the inhibition, the reproduction and release of pro-inflammatory cytokines such as EL1, EL6, EL8, TNF-alpha, and the regulation of NFK-beta. And it is also, from the previous study, also shows that curcumin regulates the anti-inflammatory cytokines, so it increases the expression, productions, and activity of EL10. And curcumin also can act directly to scavenge reactive organ species, which is released by the lung injury. And then curcumin can alleviate exudations and edema caused by the inflammations, by one of them by inhibit the infiltrations of polymorphonuclear cell and also promote apoptosis of polymorphonuclear cell. So this is a summary of the effect of curcumin in virus associated with severe pneumonia. So using in this inhibit viral attachment and then also regulations in the inflammatory reactions and scavenge reactive organ space or oxygen species and increase the expression of EL10 and also importance to block the TGF-beta collagen which inhibit the fibrosis in the lung organ. So at this stage, our research is conducting clinical trials of curcumin as an immunomodulator on COVID-19 patients. So here we have three groups of subjects. The first one is the treatment group, confirm positive RT-PCR, and then they go standard treatment plus curcumin, and then the positive control is the COVID-19 positive patients with the standard treatment, and also comparing with the healthy subjects. And variables which are measures which evaluate from day 1st until day 21st is the conversion of RT-PCR, and then also the expression of pro-inflammatory cytokines like EL1, EL2, EL6, EL8, EL12, interferon gamma, and tumor necrosis factor alpha, and also the clinical recovery. And then the second one is SARS-CoV-2 strain sequencing analysis, which is both of this project still ongoing, and hopefully the result will be available very soon. So this is for summary that SARS-CoV-2 strain have frequently undergone many genomic mutations and also cytokine storm syndrome triggered by viral infections is the culprit of the death of COVID-19. And curcumin has potential effect as an antiviral and anti-inflammatory agent for treatment of COVID-19. And the clinical trial of curcumin as an immunomodulator on COVID-19 patients is needed to demonstrate the potential efficacy of curcumin against SARS-CoV-2 infections. This is my presentation. Thank you very much for the time.
Pak Prakang masih mute.
Pak Prakang mohon di-unmute.
Thank you, Dr. Betty, for your presentation. This is the complexity to the research based on the COVID in Indonesia. Don't forget to mention your name and any question for all participation. Okay, we have the two questions. We have the two questions. The first for the Prof. Taifo. The Prof. Taifo. What did to be considered when developing the green pesticide to control the pathogen in plant? Okay, please answer the question, Prof. Taifo.
Well, I guess the main consideration really, it's need to be safe and then cheap. I mean, when you develop drugs to treat plant disease, usually you need to be able to produce in a large scale amount, and then also it's affordable or can be, can be purchased. Because it's different from human drugs that, sometimes they are very expensive and you don't have to use that much. But if you have to apply to very large area, then need to be cheap, and then also, of course, environmentally friendly. So those are, consideration that need to be taken. And then also, of course, in the case of green controls, then you have to rely on nature, right? Like natural products. And so, but in the end, if you find something really useful, but then you cannot really produce it naturally, perhaps the option really, if you can synthesize them very quickly, then that would be the option as well. Especially for certain plant infection, you just don't have anything really effective to control them. So, sometimes you have to really take many different measures really to produce something that is useful.
Okay, thank you, Prof. Taifu. And the next question for Professor Taifu again. What are the prospects for agrobacteria in realizing environmentally agriculture and the obstacle in the event of mutation bacteria due to climate change, based on the climate change obstacle? Okay, please
right.
answer the question.
Agrobacteria, well, the mutation occur all the time. It's not only with agrobacteria, but with any bacteria, right? So, and there are a lot of different strains of agrobacteria that can cause plant diseases. And the same case with Rhodococcus as well. And then, for certain plants, especially if you're talking about nursery plants, so nursery plant is being exported or being produced somewhere else, being, exported somewhere else or imported. So through that movement, actually, you can spread the disease very quickly. So the one that was infected in Europe can be easily, come to the United States. So that's common. Just like COVID, just like viral infection. Nowadays, people travel everywhere very quickly, and somebody got infected in China yesterday, suddenly now the virus is in Canada or in somewhere else. So that's also the case with plant pathogen because of the movement.
Okay, thank you. And US and Indonesia in different climates for the different potential mutation is cause, of course. Okay, the next question for the Dr. Freddy. Dr. Freddy, we have the two questions. The first, how in the efficacy of herbal medicine compound to treat COVID-19 infection? Okay, the short question. Please answer the question, Dr. Petty. Once more. How is the efficacy of herbal medicine compound to treat COVID-19 infection? Okay. Please answer the question.
Thank you very much. Thank you for the questions. So, if the question is how is the efficacy of herbal medicines in treat COVID-19 infections, that's why what need to do is like doing the clinical trial, because if based on the preclinical study or maybe the in vitro study, it maybe has efficacy or it may be effective, but the efficacy has to be done by clinical trial. So once the clinical trial conducted with very good designs, and then it shows the efficacy, or it shows, like, for example, the measurement, like the recovery of the clinical symptoms, or maybe. Thank you.
The next question. The next question for the Dr. Betty again. On the other hand, global policy demand that all drug finding on the leg be standardized by WHO World Health Organization will condition in a country. In this case, Indonesia went to immediately apply this drug. For the case in the Unair, Universitas Negeri Erlangga, finding to potential drug the COVID-19 on the case. Okay, please answer the question.
Thank you very much for the question. Actually, it's like quite a difficult question. It's very interesting question. So, WHO itself, it's encouraged for the research in drug treatment, if drug combinations or herbal medicine or etc. to treat the COVID-19. But it also cautions that all the research about that has to be done with good randomized clinical trial. So if it's not conducted with the good methodology, then it's not. I mean, it may be dangerous because we can get a false result. So I think as long as it has been conducted with good methodology, it should be all right. It come back again on how we do research in that area. So if, like, people try to have a quick decision, like, but at the end of the day, we have to see how the research has been conducted. I think that's the point.
Okay. We hope that this research can contribute to scientific development and economic value in overcoming the problem of environmentally, agriculture, and the COVID outbreak in Indonesia. Okay, apologies for limited time for Professor Taivo and Dr. Betty. So we discussion session the end and enough. Okay, I will inform the audience that question that have not been answered will be answered through a website that can be accessed in the audience. This will be further informed by the committee. Okay, ladies and gentlemen, finally we come to the end part of our presentation. We would like to say thanks again to audience for active participation. Hopefully the presentation will be beneficial for you all. Thank you for your attention. Last but not least, we come to the last session of this conference. Thank you to speaker for the scientific sharing today, and also thank you all to all audience for your participation. Thank you for Professor Taivo Mahmud and Dr. Betty Suryawati. Okay.
Thank you.
See you again in
Thank you very much.
another conference. Okay. Thank you. Next, please, MC can handle the session.
Okay, thank you so much for the session. Really impressive and interesting presentation, right?
Yes, it was.
We can see that how important plant for protecting us as antibacterial and green pesticide for preventing disease and herbal medicine to treat COVID-19 such as curcumin. Wow, I think my knowledge is upgraded now.
Yeah.
And Severo, do you think our participants are getting sleepy?
I don't know exactly they're getting sleepy, but maybe yes. But I really hope that everyone is still up and enjoying every session because it's really valuable, and as our moderator before has mentioned, that it has a really benefit for your research maybe, and then thesis, journal, and everything else. So what do we have for the next session?
The next session, this is gonna be the last session. But before that, we're gonna remind you again to mute your audio, and if you want to turn on your video, please in polite position. And for Q&A session, you can deliver your question at Zoom chat box or live stream chat box with format name underscore institution underscore question. So here she is already present, Professor Fenty Suryanti. She is now a lecturer in the Faculty of Mathematics and Natural Science in Universitas 11 Maret, Indonesia. So, please welcome Professor Fenty Suryanti.
Good morning.
Hello. Good morning.
Warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.
First of all, I would like to welcome you all to the third session of the 7th International Conference on Sustainable Agriculture and Environment 2020. In this session, we have outstanding two speakers whom I believe that shall enrich our insight and knowledge regarding the theme of this conference. They are Dr. Mithat Dairek from Selçuk University, Turkey, and Professor Dr. Muhammad Sarjan from University Mataram, Indonesia. Before the presentation begins, please allow me to introduce the presenters. First presenter, Dr. Mithat Dairek, is a researcher and lecturer at Department of Agriculture, Economic Konya, Selçuk University, Turkey. Agriculture economic is his expertise. Our second presenter is Professor Muhammad Sarjan. He is a professor at Faculty of Agriculture, Universitas Mataram, Indonesia. Now he is a head of master program at Faculty of Agriculture, Universitas Mataram, Indonesia. Pest and plant management is his expertise. First, I would like to have greeting with Dr. Mithat Dairek. Good morning, Dr. Dairek. Good morning, Dr.
Kita langsung mute sendiri atau dia? Nanti mereka.
Good morning, Dr. Dairek. How are you this morning?
Hello.
Hello. How are you this morning?
Alhamdulillah, we are fine.
Okay, it's still early, yeah?
Did you hear me? Did you
yes,
hear
I
me?
Can hear you. Clearly.
Okay, thank you very much.
And now, Professor Sarjan. Good morning, Professor Sarjan.
Morning. Assalamualaikum warahmatullahi wabarakatuh. How are you?
How are you this morning?
I am fine, thank you. Yourself? Good.
Yes, good. It is my honor for me to have both of you in this session. And I would like to remind for participants of this conference, if you have any question regarding this presentation, you may write it down in the chat room, and then the speakers will answer question in the Q&A session. Now we will hear talk from first presenter, Dr. Mita Direct. Dr. Mita Direct will give a talk entitled Sustainable Agriculture Approach All Over the World. Dr. Mita Direct, you have 25 minutes for your presentation. You can share your slide by yourself. Time is yours. Thank you.
All right. Oh, so notice. Berarti pusing. Oh.
Okay.
Yes, you can start your presentation.
Yeah. I can start. I can start, but a little bit internet problem. I think so. Oh, how can we share? Oh, I think so. It is a little bit internet problem, you know. Okay, did you hear me?
Yes, you can continue.
Okay, hello dear distinguished guests, and especially chair. Thank you very much for your invitation to my presentation. It is our conference series number 7. As you know, this conference is about sustainable agriculture and environment. And as a chairman of this conference, I'm going to talk about sustainable agriculture approach all over the world. You know that agriculture, sustainable agriculture, and three has three mentality. One of them environment health, one of them economic profitability, and then social and economic equity. So this is the all of them compared to them, then across to them, and one a little bit things and sustainable mentality. As we can see from this definition, there is no country of racism or any different identities in this context. Therefore, we all human are equal in context ecosystem. We limited, and some of them part, and there are many countries, but how is it really in one planet and one home? So ecosystem means a dynamic complex of plant, animal, and microorganism communities and their non-living environment interaction as a functional unit. So this mentality, only one planet, one ecosystems. So, nowadays there are many people and divide, and there are many countries. goal of sustainable agriculture is to achieve food safety and textile needs in the present without compromising the ability of future generations to meet their own needs. Practitioners of sustainable agriculture seek to integrate three main objectives into their work: healthy environment, economic profitability, and social and economic equity. Every person involved in the food system, growers, food processors, distributors, retailers, consumers, and waste managers, can play a role in ensuring a sustainable agricultural system. In fact, all of these problems are global, but solutions are micro. Because if people can live more simple lives, world resource can supply 25 billion people easily, but human mentality or capitalist environment are needed more and more. So humans wants more. So we can say problems are global, but solution is basically simple life. A variety of philosophies, policies, and practices have contributed to these goals. People in many different capacities, from farmers to consumers, have shared this vision and contributed to it. A system approach also implies interdisciplinary effort in research and education. This requires are not only the input of researchers from various disciplines, but also farmers, farm workers, consumers, policymakers, and others. And then, how to produce agricultural product in sustainable manner. Agriculture is using enormous amount of world resources, but in exchange it gives more beneficial goods, which is food, clothes, house material, clean environment. Sustainability means producing enough food and other goods while maintaining to produce these goals for next generation. However, as we adopt more capitalistic view, we lost the balance. Because of that, input price and are increasing day by day, and farmers have to produce more. This is completely opposite of sustainable agricultural production. And nowadays, we know that, and a virus spreading all over the world. The importance of timely, quality, open, and disaggregated data and statistics has never been as clear as during the COVID-19 crisis. Such data are critical in understanding, managing, and mitigating the human, social, and economic effect of the pandemic. They are also essential for designing short-term responses and accelerated action to put countries back to track on achieve the sustainable development goals. We know that all statistic data and COVID-19, but none more statistic data in agriculture. In response, food and agriculture trade will be slow in the world. It is where virus spreading effect. So countries has supply to need from need food from local resources. So if countries can be enough food from their resources themselves, the countries which are sustainable through this pandemic will be strong economies and will not affect from COVID-19 pandemic. In my opinion, insufficient food and food security will be important in future as COVID-19 hits the world. Some of literature are notifying to increase hunger of people in the world because of COVID-19 as like 250 million people. But I don't believe them. If we use our resources effectively, we will end hunger, and this pandemic will affect hunger is positive way since agricultural products will stay in local areas but won't be deported for money. I'm Thomas Malthus, and this presentation, and we tell to Thomas Malthus. Thomas Malthus, 18th century British philosopher and famous economist, had some ideas about population growth. His population theories were outlined in his book entitled as Essay of the Principle of Population, first published in 1798. In such book, his theory was population will continue to grow until growth is ended by disease, famine, war, and so on. He developed a model known as Malthusian growth model, using estimation of population growth. However, this theory is not suitable at present because of adverse in genetic studies. All researchers are working very hard for obtaining greater and various agricultural products. Therefore, this conference series have focused mainly on this mentality and opinion. We hope next generation should work harder for solving problems in sustainable agriculture and environment. I hope. As a result, critical discussion of the sustainable agriculture concept will and should continue. Understanding will deepen, answer will continue to come. Ongoing dialogue is important for another reason. Its main purpose to include other groups into the discussion and take their opinion and go forward towards this goal, which is the sustainable environment and future. Finally, it is important to point out that reaching toward the goal of sustainable agriculture is the responsibility of all participants in these systems, including farmers, laborers, policymakers, researchers, retailers, and consumers. Each group has its own part to play, its own unique contribution to make to strengthen the sustainable agriculture community. Now, my mentality and last word, and all problems is global, but solution is micro behavior.
Okay, I think that is the end of the Dr. Dair's presentation. Thank you very much for your informative and interesting talk. Let's give a big applause for Dr. Dair. Now we move to the second presenter. Professor Sarjan will deliver a talk entitled The Role of Integrated Pest Management in Organic Farming Practices. Again, I need to remind the participant of this conference, if you have any question regarding his presentation, You may write it down in the chat room, and then the speaker will answer your question in the QA session. Good morning, Professor Sarjan.
Good morning, moderator.
Yeah. Professor Sarjan, you have 20-minute talk. You can share your slides by yourself. And the time is yours. Thank you.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everybody. Thank you for the Committee of International Conference on Sustainable Agriculture and Environment to invite me as speaker in this conference, and thank you, moderator. And today, I would like to present my presentation with the title, The Role of Integrated Pest Management in Organic Farming Practices. I'm from the University of Mataram. Well, I would like to start my talking with the statement that pest control, as we understand, that often create its own problems, can lead to permanent damage. That's the fact. And we also understand that in the recent years, population in many pests has developed resistance to many commercially available pesticides. Many synthetic chemical pesticides are broad spectrum, actually, killing not only arthropod pests, but also beneficial organisms that serve as natural pest control system. And we understand in the fact that growers become increasingly dependent on chemical pesticides to which pests may eventually develop resistance. So, in this situation, we need an alternative approach to pest management that can complement and partially replace current chemical-based pest management practices. And what is the situation in the organic agriculture, that it is really as an alternative farming system. In the crop protection, in this system, pest control strategies are largely preventive rather than reactive. So let's have a look what is going on in the organic agriculture related to the pest control. Any strategy in organic farming should include several methods, like first, insect avoidance, second, managing the growth environment, and the third, direct treatment. And we see each method. The first method, avoidance techniques, is to manage pests, and this is effectively the producers need to understand the biology and growth habits of both pest and crop. And also we need to understand the previous crop history, pest life cycles, soil conditions, and local weather pattern. There are several methods in the avoidance techniques, including one is crop rotation as a central to all sustainable farming system actually. Extremely effective way to minimize most pest problem while maintaining and enhancing soil structure and fertility. In this way, diversity is the key to a successful crop rotation program. And diverse rotation are particularly effective in regulating beetle, also cabbage butterfly. For example, rotation with glucosinolates containing Brassicaceae can be beneficial through biofumigation's effect against soil, borne pests and disease. The second way in this technique is field sanitation or crop residues management. As we understand, insects most affected by field sanitation and crop residues management will be those that overwinter in crop residues. For example, in alfalfa seed field, the alfalfa plant bug is controlled by burning crop residues in late fall or early spring. Also, example, field sanitation is an effective preventive measure in fruit flies management. The third, host plant resistance. In organic farming, the selection of varieties with the moderate resistance is practical and even preferable. The mechanism of plant resistance are antibiosis and anti-cyanosis non-preference. There are some examples to use the host plant resistance to protect the plant from the pests. For example, in the anti-cyanosis or non-preference, we can find trichome in cotton to control white flies, woodworm in crossover diamondback moth, and so on. This is the example also. Plant resistant traits may work indirectly through their effect on natural enemies. The second technique in organic farming system to control the pest is managing the plant growth environment. In this way, the first technique is soil, to consider the soil quality management, and in this case, favorable soil conditions should be considered. For example, manure and organic fertilizer more effective than chemical fertilizer to induce rice plant growth and tolerant to insect pests such as brown plant hopper, stem borer, and leaf folder in paddy crops. Second way is intercropping. This is the practice of intercropping can reduce pest problem by making it more difficult for the pests to find the host crop. For example, Colorado potato beetles are attached to volatile from potato, Solanthurasum, but are repelled or not attracted by mixture of potato and tomatoes. This is the intercropping. The second way is mixed cropping. The literature shows that 56% of the herbivores has lower population density, 16% had higher population density, and about 28% had similar or variable density in foliculture compared to monoculture. Then, times of sowing also need to consider in the organic farming system to protect the pests. Early sowing can reduce grasshopper, aphid, and in cereal crops. Delay sowing can reduce wireworm and cutworm in cereal crops. Water management also should be considered. For example of the how water management can affect the pest control management is dryness for 1 or 2 days in paddy crop can control pests like worm maggot, rotating midge, water weevil, and caseworm. The flooding of land shortly after preparation for 2 to 3 days, effective for killing pupae of Helicoverpa and Strophtera in cotton. The example how to manage the water to control the pests. Mulch also very important. Organic mulch suppress Colorado potato beetles through a combination of effect improving, reduce host finding ability, and increase predation from natural enemies. Straw mulch has also been well studied in reducing infestation and virus incident in several crops. High population of beneficial insects acquired was intercrop with pests, and low pest pressure and higher beneficial insect population that intercropping bugpests and pests. Crab crop also very important in integrated pest management in organic farming system. For example, here in the table we can see that if we have the main crop pattern, we can use the crab crop from the marigold to control Helicoverpa amigera. Groundnut can we use the crab crop copy to control leaf folder. In cabbage, we can use the crab crop radish to control flea beetle, and in sunflower, we can use crab crop marigolds and castor to control Helicoverpa amigera and Strophtera tritura. Dead end crab cropping. Crab crop is highly attractive to the insect pests, but the crab crop does not support its growth and development. For example, diamond backmouth are attracted to yellow rocket Barbaria vulgaris over cabbage. Association with the beneficial microorganisms. For example, here mycorrhizal soybean was found to be more resistant to corn worm and for armyworms Strophtera frugiverde than non-mycorrhizal soybean. Mycorrhizal river plantain is more resistant to attack by the larvae of Archaea caya. The last way, a strategy in organic farming to apply the integrated pest management is monitoring. It is the very important activities. Insect monitoring traps are useful in determining which insect pests are present in the field and whether they are at economically important level. The type of insect hormone called pheromone may be used as a attractant to monitor population level of insects like armyworm, diamond backmouth, cabbage lover, or European corn borer. Using, for example, pheromone as other attractant, we have plenty number of pheromone that can be used to monitor the pests, like monitor insect population, monitor the disrupt mating and mass trapping. And this is also a very interesting area to use the biological control. That organic crop production rely on the separation of pests through the introduction, conservation, or enhancement or augmentation of predator or parasite. Like how to conserve the natural enemies. Natural biological control of pests and pathogens are enhanced in organic system, foster and maintain biodiversity. While growing within the near the crop field, offer results for natural enemies such as alternate prey or host, pollen or nectar, as well as microhabitats can be managed to increase the role of the biological control. Some of the important predators, as we can see here, is we have the praying manatid, we have the predator ground beetle, predator of the epidemic, predator of mite. This is the lady beetle, and spider mite, seepage flies, Redalia beetle, and western predator mite. There are many species of predators that can be improve the rule to control some important pests in organic farming. Some also can be seen here, parasitoid that can consider as a biological control agent to control the pests, like aphid parasitoids, parasitoid that's leafhopper, parasitoid, paddy dog fly parasitoid, and there are so many others. The third agent, biological agent, is pathogen of the insect pathogens that already implemented in the field. For example, from the fungi, Viveria bassiana, Metarhizium anisoplex, that can be used to control the Helicoverpa, Protera, white grub, and caterpillar, and other pathogens like Bacillus thuringiensis, that's very famous as a biological agent to control the several important pests. Natural insecticide also that can be used. It can be produced from the crops, and here in this table some example of the natural insecticide, but mostly people in Indonesia more popular using the Azarita indica or neem. Neem can be used as a natural insecticide because it can become antivedant, repellent, growth regulator, inhibit eggs, larvae, or pupa development, widely used in the management of rice pests, diamondback moth, Protera, mite, and so on. From the story, from some literature, can be seen that what is the positive effect of applying integrated pest management. For example, impact of IPM on synthetic pesticide used in celery in California. From this table, very clear that the IPM can reduce the synthetic pesticide up to 100%. It's very good news, I think, in the crop protection area. What is the impact of IPM used on carrots also here? Before IPM application compared to post IPM, this clear the significant effect of the IPM to decrease the synthetic fungicide in the area of the agriculture. This table can show that the impact of IPM used in jalapeno peppers in Mexico. Very interesting that IPM in IPM they have decreased the using synthetic pesticide from 42 to 7.5, very significant. Sorry. Okay. Cost of pest management, we can compare from the between conventional and IPM. The cost of pest management much lower than compared to conventional one. Okay. Cost of disease management also show that the cost significantly reduced from the conventional non-IPM compared to IPM1. Finally, what we can conclude from the data and information above is to successfully control pests in organic farming, it is important to understand the interaction of the different components in a specific ecosystem. IPM is essential in organic farming because it offers a wide range of techniques and practical practices to prevent or minimize damage from pests without affecting soil, water, or beneficial organisms. But to facilitate the investigation or subsequently provide a real-world solution for pest problem in organic farming, we need a multidisciplinary approach involving molecular biology, biochemistry, plant breeding, entomology, crop management, and economics. So that's all what I would like to present in this presentation. This is my activities to support the IPM especially in the horticulture crops, and now preliminary research. What we are doing now is using the waste of Virginia tobacco stem as a botanical pesticide. As we understand, in Lombok there are plenty of waste of Virginia tobacco stem after harvesting. So this waste, so far we try to use as a botanical pesticide and organic fertilizer. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for your talk, Professor Sarjan. It is a very informative and interesting talk. And please give applause for Professor Sarjan. Ladies and gentlemen, now we come to the question and answer session. Here we have several questions. I would like to read the question. First from Dr. Mita. The first question is, how the effect of COVID-19 pandemic to sustainable agriculture in Turkey? Since during the pandemic, all the activities are postponed. Please give the answer, Dr. Mita. Thank you very much.
Oh, thank you. I am sorry, and internet has a little bit problem, so we connected, not connected. Now it is good. I think so. This now, but in Turkey and getting day by day normalization. So agriculture system has no problem in Turkey because agricultural products enough for the Turkish population. So Turkey and net importer, not exporter country. So there are many agricultural products and export to other countries. So this pandemic and day by day and slowly agricultural trade, and if country is importer country has a problem, but exporter country has no problem, because problem solution is locally. If local production enough, no problem. But some place, especially African countries and maybe Asian, Southeast Asian countries, is some of problem. But the other countries, not a problem, in my opinion. Okay.
Thank you very much for your answer, Dr. Mita. I think we have the same problem with the COVID-19 pandemic. We still have one more question for you. It's from Ahmad Bayu Aryawan from Halu Oleo University, Indonesia. The question is about the utilization of local chicken in agriculture sustainable will being form paradox because some strain was protected. And if they were gathered, it would threaten the population that include. This issue will profitable the people who were down level to understand district and country resurrection. So how to reinforce the district character as part of animal ownership requirement to district progress motto. Thank you very much. Please answer the last question, Professor Dr. Mita. I'm sorry, we cannot hear yes.
Sorry, please. I couldn't listen. I couldn't net listen. Okay. Sorry, a little bit again.
Okay, I will read again. Yeah. So Ahmad have one question. Is regarding how to reinforce the district character as part of animal ownership requirement to district progress motto.
Ahmed?
The utilization of local chicken in agriculture sustainable will being form paradox because some strain was protected. And if they were gathered, it would threaten the population that include. The issue will profitable the people who were down level to understand district and country resurrection. So how to reinforce the district character as part of animal ownership requirement to district progress motto? That is the question.
Yeah, I think so. Animal production is maybe a problem because animal production needs to some input more and more from some feed. You know, animal production a little bit problem maybe, but I said again, for example, in Turkey has no problem because Turkey exporter country. If country importer country has a problem, but exporter country has no problem because all food and supply to localization. Am I right?
Okay, yes, thank you for your answer. And now we move to the Professor Sarjan. Thank you very much for your answer, Dr. Mita. And there is a question for Professor Sarjan. The question is, how effective to grow the predator to again pests in agriculture? Professor Sarjan, you may answer this question. Thank you.
Yes, thank you. That's what is the effectiveness of the predator to control the pest. That's the question. In many cases here in Mataram, we are doing some research to understand how is the predation, the level of predation of each predator to control some species of insect. In the some what we have got from the result is there are variation of the ability of certain predators to control the pest. And what we have done is mostly to test or to understand to determine the level of predation of the general predators. The point is most of the predators we have tested were general predator, mean one predator can prey several species of insects. And if we ask how is the effectiveness, we, at least they can reduce the population of the pests naturally. So there are some predators can have the high effectiveness to control the several kind of pests. That's the answer.
Thank you very much for the answer, Professor Sarjan. And I have one question. This is my question. Since I am an organic chemist, I want to ask about organic. How effective is using naturally organic compound in comparison to synthetic chemical compound for pest control? Thank you.
Okay. I think an interesting question. That's everybody have the similar question with you. How is if we compare natural pesticide to the chemical pesticide, how is the effectiveness? From what we have done, we still have the effectiveness of the natural compound mostly lower than chemical pesticide, mostly lower. But we still try how to improve the effectiveness of the natural compound. At least can probably the effectiveness of this compound similar to the chemical ones. But again, what we have done is the effectiveness of natural compounds still lower than chemical one. That's the answer.
Okay. Thank you, Professor Sarjan. Maybe we can also combine, between the organic compound and the synthetic compound, so we don't use too much synthetic compound in as compound.
I agree that we also can be done combination between one way to others. That's a good idea, I think. Thank you.
Okay, thank you, Professor Sarjan, for your answer. Ladies and gentlemen, finally we come to the end of the last session in this General Assembly. Before ending of this session, I would like to highlight, it's come from Dr. Mithat, direct. All of us have to work harder for solving problem in sustainable agriculture and environment. All of us has our own part to play because we have own unique contribution to sustainable agriculture and environment. That's what I can highlight in this session. And I would like to say thank you for Professor Dr. Mithat and Professor Sarjan for the informative and interesting talk. And I also would like to thank to all audience for your active participation. Hopefully this presentation will be beneficial for everybody. And I do apologize as I have mistaken during facilitating this session. Thank you for your attention, and I give the time back to the MC. Assalamualaikum warahmatullahi wabarakatuh.
Okay. Wow, that was really insightful and very useful for our participants here. And as they have presented before about in sustainable agriculture implementation, not merely for the farmer that contributes, but also there are laborers, policymakers, researchers, and another contributors that should contribute in the implementation of sustainable agriculture. And it was really interesting for the question and answer, right?
Yes. We can see there are a lot of questions in the chat box, and those are really out the box.
Yes.
Okay. By the end of the final season means that we have finished this conference.
But hold on, we need to take pictures together with our participants here before we finish this conference. Okay, I really hope everyone here is open the camera in a flat position.
Yeah, and please give your best smile.
Yeah, you can also wave your hand, say hi. Hi.
Everyone.
Wow, there are so many participants here. Okay.
Okay.
How many participants here? Wow, so...
I think above 100.
Yeah. Okay.
Okay. Give a pause, right?
Yeah.
And we will lead the
Yeah.
photo session.
Give pose.
Pose,
You can
please,
pose.
You can pose.
Give your best smile. Okay, I will count. I will lead the photo session.
Okay.
On the count of 3. 1, 2, 3. Again,
Yeah.
give us
Another pose.
another pose. You can wave your hand.
Raise your hand.
Wave your hand. Raise your hand.
Please open the camera.
Yeah.
Okay.
1, 2, 3. Again.
Again.
For the participants who haven't opened the camera, you can open the camera. Yeah.
Okay.
Wow.
Okay, two more ya.
Okay, two more. Okay, two more.
Okay. Another pose, please.
3, 2, 1. Cool. One more. One last photo session.
Yeah.
Okay. Give your thumbs up.
Thumbs up.
Thumbs up. Thumbs up.
Okay.
Jempol.
Wow.
Sorry,
Okay.
sorry, we speak Indonesia. 1, 2, 3. Cool.
Okay, thank you so much. That's all for our photo session. So that's wrap up for the event. Thank you for attending this event. It has been pleasant to become master of ceremony today. We hope that this event can give a new perspective about agriculture in this pandemic situation.
Yes. Oh, anyway, there is an announcement for the participants from the organizing committee. The announcements are, first, the digital venue of parallel session still can be accessed until 3 p.m. GMT +7, and the certificate of the participants and presenter will be sent through email. And last, if you need further information, please do not hesitate to contact the organizing committee.
Yes.
So, okay, we look
Okay,
forward to seeing you
in the next year event.
My name is Elviro.
And my name is Chris.
We are checking out. Goodbye, everyone.